Hi, my name is Zsuzsa Hódi. I'm an iOS developer at EPAM, and today I would like to give you just a quick perspective on how SwiftUI works. First, I will give you a quick overview of the SwiftUI structure, like view updates, what environment is used for, and then I would like to squeeze in a little demo as well. I hope you'll enjoy that part as well. So first of all, how are the views constructed? How are the layout constructed and then updated? Here you can see a little basic view with just a little bit of code here. As you can see, we have a vertical stack with a button and text. If the button is tabbed, then the text changes. Before any of the changes were made, you saw you've not yet tabbed, and after that, as the state variable of counter changes, the text is updated accordingly. This is the code that I will use for the basic overview of SwiftUI. So it's a view tree that you can see here. It is the abstraction of the view. It's an entire structure containing not just those views that you can see on screen, but those that could be shown as well. So for instance, if you see there's a conditional content with two texts, one of them is shown if the counter is set to 0, and the other one is shown when the counter has been changed. When that counter variable is changed, we get a new tree of view values and the screen is updated. We will see some view builder functions later. What you need to know about them is that they use a very limited subset of Swift. So, for instance, if you know Swift, guard statements are pretty useful. I love them a lot, but inside view builder functions, you cannot use that, neither loops, but you can use if-else statements or switches. The only thing is that they need to return a view or conditional content, modified content, or a tuple view. You see also view modifiers on screen under the button, like corner radius, background, and padding. All of these view modifiers adds an extra layer in the view tree. And this is why it's important to give them the order that you want. For instance, if the button was 40 pixels wide and you wanted to give it a 100 pixel padding, then if you add padding first, then the background will be 100 plus 40 wide. But if you add background first, it will be 40 wide. I hope I made myself clear by how important the order is here. It's the same tree, but a lot more simple. So how is the view laid out? It starts at the outermost view. It's at the top of the tree. Now it's a V stack. It's short for vertical stack. It means that items will be pegged under each other, and it has a certain amount of children. Now, the entire space that the V stack gets should be divided equally between its children, the button, and the conditional content that can be one of the texts. But, and here comes the tricky part, you see all those view modifiers added on the button, and the padding will change its size. So first, it calculates the size with the padding, and then the final size will be reported back to the parent. This is how the sizes are calculated, but there are often times when the available space is not used. This is when it's censored on screen, like you saw in the first video. Now, how are the views updated? there's only one way in SwiftUI to trigger view updates, and it is by changing straight properties like the counter variable on the top. So there are certain property attributes that need to mark the properties, and if those change, then the view tree needs to be reevaluated and then compared to the previous one, and then the body property is accessed again, and this is how in the end we will get the updated view. How exactly it happens? So probably you've used the imperative approach because this is the classical way to create applications. It has two view-related paths. The first one creates the initial construction of the views, and then the second one updates the views directly when certain events happen, like, for instance, when you tap a button. The thing is, it's very easy to make mistakes. Probably you have made mistakes as well during coding. But this is what the declarative approach of SwiftUI prevents. It has a single code path that constructs the view, and the single path will update it. It's impossible to bypass the normal view update cycle. You cannot modify the view tree directly. The only way is to trigger the reevaluation of the body property. What happens is that we have two view trees, the old one and the new one, and the two are compared based on what property has changed. So obviously, in our previous example, we wouldn't compare the button because it wouldn't change, but we have changed a property that would trigger the update of the text. And now, how can these trees be dynamic? For instance, we had a conditional content with the if-else statement, and we can also have collections like lists, arrays, but only with a view called for each. We can also have any view, which means that it can wrap any view, but the tricky part is that now we won't know, SwiftUI won't know the static type of that view, and it will be an essential information for the efficient view updates. With any view, the structure of the view tree is not static enough, so the comparisons will be less efficient. We will also talk about view builders a little later, but those are what we need to get the views. No other hacking functions can give us views, just view builder functions. Now I've talked about certain properties that need to be changed in order to trigger view updates, and these are the so-called straight property attributes that we need to talk about. The most common property wrappers are state and binding, and observed object and state object. What the key difference is, state and binding are just one values that can be changed, while state object and observed object are complex ones, like a view model, for instance. You can have a lot of properties that can trigger view updates. And the difference between state stuff and the other is that if you mark anything by state, then the view owns it. So with the previous example that I had, the view owns the counter state variable, but if I had a subview with a binding variable, then my view would give it like a pointer. So binding variables are like pointers to the state variable, and the same goes for observed object and state object. So they are just passed on There's one more very often used property wrapper. It is environment and environment object. It's a pretty awesome thing in SwiftUI because environment just passes down the same value from the parent view to the subviews. So for instance, I can say that, okay, I have a list with a lot of text views, and if I add the same font to that list, then all of them will have the same font. I don't have to add them one by one. The same goes for an environment object. It's kind of like a dependency injection here. You see, if on my view, I want to use an environment object, for instance, a database connection, it's like a normal variable that can be accessed. It just needs to be injected in its parent view. So as you can see, I don't add it to my view in the example, but to the navigation view. So if I had my view 1, 2, 3, 100, all of them could reach this environment object, and I don't need to do this one by one. Here's the font example. So I have a vertical stack with a text and the horizontal stack. Now I add the font variable on the horizontal stack, so text 2 and 3 would get the same font, but the one in the V stack outside of the H stack wouldn't get the same font. We have, in the second example, we have color scheme, like you know about light mode and dark mode probably. And so for instance, we have the circle, which we can fill with the color that we want based on the color scheme. Now, it's something that is in the phone, but you can reach this color scheme in any app because it is an environment variable. So as soon as it switches to dark mode, the circle will be filled with white color instead of black color. And now it was the boring part, perhaps. Let me get to the demo. I made a really basic app for image search. It's just if you type any words, it will go to Shutterstock, fetch a few images, list them, and you can open a more detailed view with a bigger picture and a description. You have search history, which you can clear, and you can go back to search. Now, a little coding here. You see the property wrappers on top. We have an environment object, an environment value. Now the environment object is an observable object with a published var that is a UI state. You see above that it is an enum, and one of the cases have an associated value because when the images are loaded, this is the change that we make. And you can easily access those images in the further view updates. The environment value is the managed object context, which is part of the core data that we use for persistence here. And both of them are injected in the main abstract. The environment value is from the shared persistent controller's view context. And the environment object is the app state that is initialized as a state object here. See, the abstract owns the state object, and then it is injected into the search view and, well, everything under search view. I'll try to forward it a little bit. I'm sorry. Okay. I'm sorry, at home I had a search bar here. But while it's playing, we will also have a view model, which will be also an observable object with a published value, same as here. And the search term will be a more tricky one. That's why I wanted to fast forward there, because search term is a state value, but we can use either its binding value or the string that it actually is. And the binding value will be needed for the text field, because it requires us to provide a binding value to it. And it looks like it's dead again. Okay. No, I cannot fast forward. Okay, so okay. I'm sorry, I'm talking about something that is not on screen. But the thing is that the binding value or its normal value can be used. But I will talk about this later, so I won't wait for the video to reach there. I don't want to waste precious time on it. Now let's see the body property. It has view builder values and view builder functions. As you can see, it's based on the UI states, the enum that I've showed you before. It has the initial view, ready to search, loading, loaded. So for all app states, I have a view that conforms to that state. The initial and the loading states are similar, just the text is different. That's why I have view builder functions and not variables for that. Because for them, I will need an input value, which will be the text under the image. I honestly hope you can see it, because at home I could pause the video, but it was way too quick, so probably you didn't see it at all. But there's a pretty awesome new thing in SwiftUI. You have a symbol effect. It means that you can have animation-like things on images. Maybe you just see it for 1 second. And another awesome thing is the gray gradient that you will see, because I don't want to waste time on modifiers and stuff. So in the background, you have a gray color gradient, which is built in to SwiftUI. So I didn't change anything. You see a slightly lighter gray on top and a slightly darker in the bottom. It's built in. And the ready to search view is what you saw a lot of times, because it was staying there. So it contains of a history and search bar, and well, spacers push it to the middle just in case. History and search bar has 2 buttons and a horizontal stack with an image and a text field. Here you can finally see the search term that I was talking about in line 75. That's the binding variable of the search term. You see it's marked with a $sign. That's why it's binding. I need to use in line 81 search term without a binding value, because we'll load the images based on a string value and not trigger a view update based on a binding value. And, oh yeah, as you can see, the view modifiers are the same on both buttons. And it's an awesome way to create a custom modifier, but here at least you get to see more of them listed here. It's also worth mentioning that corner radius needed to be added to the button, but for the text field, we already have text field style as a view modifier, just for text field. This is the most exciting view, I think, because here I reused the history and search bar on top, and I have a navigation view under it. It means that the navigation view as a list of navigation links, it provides a view for navigation. So if I tap one of the images, history and search bar will remain there, and the details view that is provided by the navigation link will only be rendered above the navigation view. As you can see, we also have an async image as a label of the navigation links. I also find it pretty awesome because here I don't need to handle any async code. I just let SwiftUI know that it's an async image. It will be downloaded from the internet. Please give it time, and it loads it async without doing any other threading or any complicated stuff. Now, the history is a bit more complex view. It has its own view model because this is what handles the persistence. So when I download an image from the internet, well, not the image, just the JSON, I will save all the data into core data, and so I can retrieve anything I need in the future. For this, I need to provide the managed object context to the history view and its view model. But I also need an app state in the view model and in the view because I have a back to search button. So when I hit back to search, I would change the UI state of the app state, and it will trigger a view update. But I also need to change the app state in the view model when the images are loaded. And maybe I was too quick, but this is what I had in mind for you. Is there anything you would like to ask or anything you would like me to go back to? Or anything that was not clear in the middle and you would like to know more about? Yeah?
What sites could we use to understand more on how to use SwiftUI?
There's a pretty good documentation on on exactly SwiftUI, but what I usually do is listen to Paul Hudson on YouTube. He has a great channel. That's my best suggestion. Yes?
Regarding SwiftUI, you were a potential candidate and interview for you there?
I don't know much about that. If you go to the standout side, they will probably answer to your question. But we do have a lot of iOS developers at EPAM. Any other questions? Well, if not, then thank you very much. If you're interested in the source code, you can see it on my GitHub. And have a great day.